This video will cover how to interpret a binary decision tree in the Azure Machine Learning Studio. With decision trees, numeric and categorical variables can play the role of being input variables and the role of being output variables. It's common to have both numeric and categorical input variables either when predicting a numeric or a categorical outcome. I will first explain how categorical variables as inputs and outputs are interpreted with the decision tree, and then I will explain how numeric variables, both as input and output variables, are interpreted. In this example, we are predicting whether mushrooms are edible or poison, so the outcome variable is a category, and we're using a series of categorical variables to predict whether they're poisonous or edible. The first one that is the most influential is the color. Azure makes temporary variables for each category within a categorical variable. So for example, if you have a series of colors, then what it will do is it will create a temporary column of data, one for brown and one for green and whatever other colors. They each have their own temporary variable. So when you see color.brown, this was a variable that was manufactured by Azure from the categorical color attribute, and if it is brown, then this attribute is set to 1. Now you'll notice that underneath here you have less than or equal to 0. So basically what this is saying is color brown, if it's 1, then we're going to go down this side of the tree. Now by clicking on edges here, we can see the true and false. So if color.brown is 0 or less, then it's not brown, and it's going to go down this side of the tree, and then it will test to see if there are 2 rings on this particular mushroom. If it's not less than or equal to 0, that means color.brown equals 1, and so we go down this, and then the next thing that would be tested to see if the mushroom has narrow gills. If the mushroom doesn't have narrow gills, this is 0, and therefore this expression, the overall expression, is true, and we go down here, and then it's predicted that all of these will be edible. Otherwise, gills narrow is true. We have 60% of the mushrooms being poisonous and 40% of them are edible. So this is an example of a terminal node down here that is mixed. The decision tree couldn't do any better than this. So to see more of the tree, if we scroll this down, we're able to see terminal places on the tree, or when you get to the bottom of the branches. And so we can see that we have mixed ones. We have some that have been sorted correctly into either all edible or all poison. These are all edible. This is all poison. And then this one is 100% edible. And then this is mostly poison. Do any better than this? So that's an example of interpreting an Azure decision tree when it's dealing with categorical variables. Now back and look at the scored model and look at that visualization. In the scored model, then we're able to see the value of the attributes for each of these various characteristics, and then we're able to see the scored probabilities. So this is edible, this is poison and edible and so forth. You'll notice that values that are in between 0 and 1, in other words, they're not 0 or 1, are a probability that it would be poison. So for example, this is 0.59, saying that there's more than a 50% chance. It's a 59% chance that this is poison. Where you see a 0, the decision tree says it's certain that it's edible. When you see a 1, it's certain that it's poisonous. Here's one where it's almost certain that it's poisonous. So that's how you evaluate and interpret this aspect of it when you're really looking at the scored data set. Now, if we go look at the model evaluation, we visualize that, it gives us a number of statistics that are helpful. In this one, it is giving us the confusion matrix. So in this case, it's saying that its true positive is 631. It was accurate 96.8% of the time. It didn't have any false negatives, and it had a lot of true positives and a lot of true negatives, and then this had a false positive. So interpreting this false positive, then, it is basically saying these are mushrooms that it thought was poisonous that were not poisonous. Because it has no false negatives, then it's basically never going to tell us that we have a safe mushroom that is really poisonous. The kinds of mistakes we're making here is saying safe mushrooms are poisonous. So this is the least costly mistake that it can make. It essentially will throw mushrooms away that would be editable that we're not going to eat because we would worry that they wouldn't be editable. So we'd have to come up with a stronger classification if we were going to try to squeeze down this number of false positives. Now, this model shows an example of using numeric predictors, and it also has a numeric outcome variable. What we're trying to predict in this model is the percent body fat, and we have various attributes about the circumference of abdomens and wrists and things like this, and age in years and weight and so forth. Interpreting these numeric variables is a little bit different. You might recall that when we were looking at categories, the expression down here was less than or equal to 0. When you're doing a numeric variable that is a predictor, instead of it being less than or equal to 0, the values down here are whatever the values need to be to provide the very best split for the decision tree. So by turning on the little edges feature, we can see the true and the false parameters are branches. And so the first decision is abdomen circumference less than or equal to 91.85. If it's true, then it goes down and tests if abdomen circumference is less than or equal to 85.4. And then if that's true, it goes down and tests age. And so it's easier to read them in terms of moving down this true thing because it just matches this expression. If this isn't true, in other words, we have an abdomen circumference that is 91.86 or larger, then we go down this branch. If abdomen circumference is greater than 102.95, then this expression is false and we go down here. If the abdomen expression is greater than 43.5, then we're going to go down here and make the estimate of body fat percentage of 6.74. If the age is less than or equal to 43.5, then the percent body fat is equal to 5.59. You can see along the bottom of the tree that we have these various estimates of percent body fat. So depending on how the decision branching is done, then you get down to these various and different estimates of percent body fat. Let's go look at the score model results and visualize that. In the scored model results, what you get is you get the scored label. So this is the percent body fat for each person in terms of what the estimate came up with. Now in terms of evaluating the model, if we visualize that, then what we see here is a series of model fit statistics, the mean absolute error, the root mean squared error. Basically, within percent body fat, we're coming in with about 14 to 16%. This histogram shows you how big the errors are in terms of a distribution. So very small errors up to very large errors.